Hello once again. My name is Peter Hue. I'm your facilitator today on this fundamental course for data analysis using R programming language. Abada Shotomiwa, can you please mute your mic, please? Great. So we'll start by introducing you to the classroom, give you a walk around the classroom so that you familiarize yourself with the classroom. We'll keep admitting people into the class, so there'll be occasions where we'll have to go and share the entire screen so that people that are joining will be admitted in. Just ensure that you remain excited all through. All right, I hope you can see my screen now. Can you see my screen?
Yes, we can.
Great.
Yes, sir.
Okay, great. So I'll take you to the classroom now. I said earlier on, I sent a message to the group that it would be better for us to join with our laptops or our desktops. It's easier. So on this platform, we have 4 different rooms that we can go to. Okay, sections. So in this first section, that's where this is like your landing page. This is where you get to once you link to this classroom. And here we can, do our recording. You can join the class. Please don't share this code with anyone who is not in this group. And then there are already materials here which you could have related with. But if you've not used this platform before, make sure you keep coming here. Another platform that is useful is this YouTube, link. So I'm going to copy that link, paste it on our platform so that you can visit it and get materials beyond even this course. You will see materials for related courses. All right, good. That's a good starting point. All right, so later on, we'll look at the course outline. We'll look at, we don't need this for now, although we'll come back to it maybe after this class to ask us to register those who have not joined yet, because there's a large number of people who haven't signed up to our Google form. The HOD of statistics, I think, Dr. Samuel, kept telling me that there are people who wanted to join and we needed just to add their telephone number, so we couldn't send them the link. But moving forward, there'll be a need for us to send this link to everyone so that we can have your email addresses and ensure that you are part of the class. All right. So this will be our material for study today. We are going to cover this material. Our class is going to be in 2 major sections. One will be the delivery of the lecture. The other will be hands-on exercises. However, to make it very interesting, we are going to intersperse them. We'll have the lectures and then do some practicals, then continue with lectures and then go back to practicals. That's the method that we're going to adopt for today, being the first class. But moving forward, we could adjust the whole process depending on the need. It all has to do with what we discover that people need. So please feel free, engage us on the platform. Okay, let us know if you have issues. Let us attend to those issues sometimes before we come to the class, so that in class we can maximize the time. 2 hours is enough for us to do a lot. But if we have to come to class and start doing other things, we might waste a lot of time. So without wasting so much of our time, let's look at the course outline. Okay, let's just zero in on the course outline. Okay, you only need this is what you need. Okay.
Somebody is raising hand.
Okay. Okay, so Mercy Olugu, go on. Mercy Olugu. I think that hand is accidental. Mercy Olugu. Mercy Olugu, please, can you mute yourself? Okay, so we are going to have this kind of problems today because it's our first lecture. But moving forward, you need to learn that when you join these platforms, you need to mute. Mercy Olugu, can you please mute yourself? Mercy. And somebody put a message on the chat to tell Mercy to mute. This is going to disturb us. Hello, Mercy Olugu. Hello, Mercy. Hello. Hello, Mercy. Can somebody please help me send a message to Mercy Olugu? There's background noise and it's not going to. Hello. 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 Hello.
Move everybody on your side. From your side, you can move everybody.
Yeah, but by the time you want people to talk, they will not be able to talk. Okay, let me just go on. Let's just hope that at the end of the day. Okay, good. Fantastic. Thank you very much, Mercy. But again, you've gone back to.
Akim left.
Okay.
All right, can we go on? Hello. Great. We've taken some time trying to admit people into the class, taking some time trying to get the ground, the work started, but we'll be fine. All right. I hope you can hear me. If you can hear me, can you just maybe just wave hand? Anybody can hear me? Can I go on? Can I go on? Yeah. All right. Okay. Thank you very much. Thank you really very, very much. So the objective of this course, okay, is here. And there are 6 key objectives. The first one is to understand the core concepts of data science, not just data analysis, data science, including the different phases, the tools, and the applications. That's the first thing that we intend to achieve through this course. So to understand data science as it were. Secondly, we want to master a programming language. There are so many programming languages, and there are a few of them that can be used for data science. R is one of the top programming languages. So our second goal in this class is to master the rudiments of R programming, especially with regards to data manipulation, cleaning, and analysis. Our third task is to introduce us to data visualization using R. And the goal of data visualization is to identify patterns, trends, structures, and also to extract insights from data sets. There are several R packages that are used for doing that. In fact, that's one of the major strengths of R programming. There are many things we are going to say about R as a tool for data science and data analysis. But we cannot say too many if we don't first mention data visualization. Data visualization is at the top when you are looking at the advantages of using R. Then we'll go on and we'll look at statistical models. How do you apply them for data analysis? And if you recall at the beginning, I said that we are looking at data science, which goes beyond data analysis. So subsumed in data science is data analysis. So as we go on that journey, we are going to look at how we discuss statistical models, and there are several of them, okay? But our major emphasis will be for data analysis and inference. We'll be looking at models such as linear regression and other regression models, and then the classification methods. So we'll look at regression where you predict a point, and then we'll look at classifiers. Again, another objective is we want to make us gain practical experience with machine learning techniques. So the fact that we are doing data science means that we will touch on machine learning. We will explain the term, we'll look at the techniques like decision trees, random forest, support vector machines, and how they are implemented in R. And finally, it is also very important, we will all together learn how to communicate data-driven insights from visualization and then eventually writing reports. So welcome on board on this very interesting flight. Fasten your seatbelt because it's going to be a very interesting ride with some, bumps on the way. Yes, so next is to look at the structure, look at the content. Just a high-level view. That's what we are going to give you today. So in today's session, we'll be introducing you to data science and R programming. So there are two parts to it. There's data science, and then you will hope that by the end of this class, you understand what data science is about. You can then discuss it freely. You have a direction of what a data scientist does, and then you look at what are the things that are involved in data science. Then the second half of the class will be R programming, which is a tool for us in this class for implementing data science. Other lectures, sessions will include data wrangling and manipulation, visualization in R, statistical modeling, machine learning basics, and then we'll pick some machine learning methods like random forest and other assemble methods, because it's not alone in that category. We'll look at support vector machines. We'll look at supervised learning techniques. And towards the end, we'll build projects and then look at what are the emerging trends in data science. And there are lots of them. So there are some prerequisites. We don't know if you have fulfilled those prerequisites, but let's talk about them. Basic knowledge of computer programming concepts. Okay. Familiarity with basic statistical concepts, and then access to computer with R and R Studio installed. So we are going to do this today. We are going to install R and R Studio and start making use of it. But before then, I want to find out from us, on a scale of 1 to 5, let's add some more people to class. On a scale of 1 to 5, go to the chat and rank yourself with regards to computer programming. 0 meaning I've never done computer programming before, and 5 meaning I'm an expert at least one computer programming language. Let's do that exercise. Let's just go to the chat and just put a number. Okay. So the question is, okay, Adeshaye Ogutole 3, meaning that I'm comfortable with the programming language. Ahmed Olarewaju, expert. Ola Anishola 2, upcoming. Yes, let's keep them coming. On the scale of 1 to 5, 0 means complete novice, 5 means expert. 3, Sulaiman, great. Let's get a few more. Okay, so sometimes it's difficult to rank yourself, but let's just have an idea. Okay. By the way, if you have expertise in one programming language, it's an added advantage. Tawa Yomide 3. Okay. Okay, yeah. So 5. There are some very interesting. Maybe towards the end of our lecture, we could do things like breakout rooms and have group projects and all of that. That will make it very interesting. Okay, so let's leave that poll alone. Can keep it running. So today's lecture 1, is an introduction to R. Okay, it's an introduction to R. And this is by Professor Oyolubusoye. I'm presenting on his behalf. All right. So before we go to R, which is the practical aspect, let's talk about data science. Data science is an interdisciplinary field. Okay, don't get it wrong. It's not only for computer scientists. That's one of the misconceptions. A lot of people hear that they hear about data science and they are scared. But it's an interdisciplinary field. What does it do? It combines statistical methods, programming, and domain expertise. So even if you are not a statistician, you don't have a strong background in maths and statistics, and you have not done programming before, or you don't have idea of programming languages, there's always a field where you operate. And in that field, you're expected to be a master, an expert. Therefore, there's a room for you in data science. Okay? There's a room for everyone in data science. So long as the project requires your expertise. Because your expertise in that area will help to prove if the results that are derived from the statistical methods and programming are, acceptable. So what kind of expertise and what kind of statistical methods and programming do we really need in data science? It is the ability to extract insights and knowledge from both structured data and unstructured data. What do we mean by structured data? There are several ways you can look at structured data, but the easiest example is to look at data in form of a spreadsheet, an Excel sheet, a CSV file. That's structured data. But that's not all. There is also a need to extract data from images, from text, from video, and all of that. So data science has evolved beyond mere data analysis to extracting insights and knowledge from unstructured data. So that is the general definition of data science. And that's the working definition that we're, applying in this class, in this workshop, in this program. So what are the major things involved in data science? There is the collection of data. Then there is the cleaning of the data. And after that has been achieved, there's analysis and visualization. Finally, there's interpretation of data to support decision making. So this is like an end-to-end process of data science. And then we can break them down further by saying that the key components in data analysis are: 1, data collection, which takes the chunk of the time. A lot of newcomers to data science do not realize this. Sometimes most people think that the most demanding aspect of data science is the machine learning and predictive modeling. Of course, that's important. That requires a lot of technical know-how. But data collection, which not only is the beginning of the entire process, is a very tedious aspect. So let's put that at the back of our minds as we proceed. Now, when you collect data, data is usually messy, usually very, large. So there's a need for you to clean it, put it in a format that is, acceptable for the next stages. Then once you have that, there's need for you to do quick analysis of the data, check for some descriptive values before you move on to machine learning and predictive modeling. And then there's visualization to complement your efforts. And ultimately, for a data scientist, you need to have skills in communication. So a data scientist needs both the soft skills and the hard skills. Hard skills, which could be the programming skills and the machine learning methods, and even data collection techniques. You also need soft skills like ability to communicate your results, to tell a story from your results. That's also important. That's why the data science process is a very collaborative one, such that if you have a team with diverse expertise, then the tendency to produce a solution that is easily understood by the user, will come very handy. So we'll move on to this, next slide. And this is not exhaustive, but these 5 bullet points that have been selected are some of the most important usage of data science. First, it helps us to make data-driven insights for our own business or businesses of other people when we are hired as consultants, for government, and as researchers. In the same way, you are able to predict the trend and automate processes using data science. Also, you can help to customize customers' experience. So customizing customers' experience is one of the major usage of data science that all of us experience. There's recommendation system, which we will talk about as we proceed, where when you go online and you want to buy a product, and then you see that some other products that you'll be surprised that you actually like are recommended to you. So that's one area where data science has flourished. Then in healthcare and medicine, yes, data science can be used to identify disease patterns in discovering drugs and, making sure that healthcare for patients are maximized, optimized. Then it supports machine learning models that drive automation and smart technology. So a little gist about AI, data science, and machine learning. Maybe I will digress a bit and show us that so that to deepen knowledge. So we can go here and write AI, ML, PSDL, for instance. Can do images. Okay, so there could be so many, but let's stick with this one. Just to show us that the whole idea around AI and its popularity is not far-fetched from what we are doing. Of course, we are doing data science, but it could be, we could say that data science is a less fanciful name for artificial intelligence, to say that artificial intelligence looks so fanciful. But let's look at this diagram. So here we have AI, okay? We all did set in school, okay? So we have artificial intelligence. Within that bracket, we have machine learning. And within machine learning, we have deep learning. Then here we have math, statistics, visualization, and exploratory data analysis. So the merger here, just to show you how strong data science is. So in data science, you find AI, machine learning, deep learning, math, statistics, visualization, EDA, and many more. I hope that makes us glad that what we are doing is something that encompasses a lot of fields. And finally, data science helps us to detect fraud and helps in cybersecurity prevention so that threats can be quickly discovered using predictive analytics. So again, now trying to look at specific examples of the application of data science. In business and finance, we can apply data science in understanding customer behavior, perform risk management and fraud detection. We can predict stock market prices. We can even to the extent of blockchain and cryptocurrency. So in business and finance, data science has been applied and is still being applied heavily. We have talked about health care and medicine for diagnosis of diseases using machine learning methods, having personalized treatments and providing recommendation, and for medical image analysis. Allow me to go back to the class because I heard a bell now which indicates that somebody has either raised hands or is trying to join the class. Now I have my own issues. My issues are I have too many tabs open. So let's go here. Yes, any hands up, any comments made, we are okay. Good to go. Please, let's suspend all comments and reaction till later on so that we can cover some content and then we'll come to the hands-on. There is a lot for us to cover. All right, great. So in marketing and e-commerce, you can help yourself and other organizations to do targeted advertising. And of course, that will bring in more profit when you advertise and you get returns for your advertisement. And then in even large conglomerates like Amazon and Netflix, they have the recommendation systems in place. And they can also do sentiment analysis to understand the perception of customers to your product, their feelings. Then government policy, in policy making, okay? So data science has been applied in building smart cities, in forecasting economic trends, and also monitoring public health issues. It was in use during the COVID and has always been in use even before then. But I believe that it must have also influenced the rate at which some of the medications, the drugs, the interventions for COVID-19 were quickly brought up. And that also depends on where you lie, whether COVID was real or not. So also there's application of data science in engineering. It's popular used in climate change is a global problem. In genomic data analysis, in manufacturing processes, data science has found its use. So if we also know that there are students in this class. So as a young student or a middle-aged person or even an adult who is trying to change career, okay? Not everybody comes to learn data science with the mind of changing career. Few people come just to acquire knowledge, but a whole lot of people want to change career. So even though we are looking at data science, under that umbrella data science, there are many career opportunities. So you could end up being a data scientist and your work will be using statistical and machine learning techniques to analyze data. Or perhaps you're a data analyst whose work is to interpret trends and patterns for the purpose of informed decision making. Or maybe a machine learning engineer. Yours is to, along with us, some of these things are not done alone, develop AI and predictive models, okay? A business intelligence analyst is also a data scientist. The work there is to create reports and dashboards for business insights. And there are tools outside there, some of which do not even require learning programming languages. But when you now know our programming, you can then produce a more dynamic, a more sophisticated dashboard. By the way, we'll still come to all of that in subsequent lectures. So we're in the world of big data. Plenty of data, the speed, the volume. Just imagine the amount of data that is generated by Meta, that's Facebook. So there will be need for engineers who can manage such size of data. So a big data engineer is one who manages large-scale data, process, and then beyond processing, also storage. If that is a big data engineer, then a data engineer does the designing and maintaining of the architecture. And then the statistician, which some of us are, we apply statistical methods to data analysis and research. So back to what skills do you require to thrive in this area? You need technical skills, which I've referred to as hard skills. You need to know at least one of these programming language. If you know more than one, better. We are focusing on R now. In other iterations of this program, if there is time for that, we will look at Python and SQL. Okay, so Python is just like R, but SQL is something else. It's a structured query language. Then you need to have a background, maybe grade 12 level of statistics and probability. I mean SS3 level, school SAT level. If you have more than that, good. Then, apart from knowing R programming language, that is the fundamentals of R, there is need for expertise in data visualization because pictures speak a lot. And some of the very popular, very popular plotting, tools, sometimes libraries, are ggplot2, which is a package in R, Tableau, and Power BI, which are for other organizations. Okay, then there's machine learning and AI. And we are going to cover some aspects of this. Okay. At the end of the lecture, you would have improved in some of these areas. The only area where you need to read up a lot on your own will be statistics and probability. For the soft skills, we are going to be having exercises, we are going to be having hands-on, we are going to be giving you problems. And as you solve those problems, you need to think critically. So in the end, as a data analyst or data scientist, you need to improve your problem-solving skills. You need to know how to think critically and creatively. You need to know how to tell a story, communicate your results, ask questions, and then determine what domain you want to focus on. So there's always one domain where you have, expertise. Because data science on its own does not solve any problem except it's applied to a particular field. So at the end of the day, the future of data science is such that there is a growing demand for it. The need to make data-driven decisions is ever growing. For instance, the president of the United States reportedly has earmarked $500 billion. I hope I'm very correct. You could check that online. $500 billion to artificial intelligence projects. And we've already seen that data science and AI are like, synonymous, terms. So beyond that, there is need for more automation. You've heard of self-driving cars. You've heard of household equipment like Siri, a lot of household equipment that are able to do chores for us. In fact, robotics also requires some knowledge of data science because that is also data-driven. Then deep learning and AI-powered analytics are really growing. There are issues around mental health everywhere in the world. Climate issues, energy matters, neuroscience, and all of that. So the need to advance in AI and machine learning is important. And then with the advent of generative AI, the use of pre-trained models, the common one is your ChatGPT, which now has rivals, okay? Rivals, even by the Chinese people, the DeepSeek. I don't know if you know some of those things, but as we go on, we are going to see the ethical use of those models because there is also need to talk about ethics. And then there are other emerging fields like quantum computing, edge AI, real-time data processing. There's even agent AI and lots more. So you've now come to a field where you have to always check online to know the new trends, because sometimes the tools that you are using might be updated, obsolete. So what then is the data science workflow? It's a systematic process used to transform raw data into meaningful insights. So so you have a dump site with a lot of refuse, but in that dump site are hidden very precious materials, and then you now go there. Like I don't know if you have seen scavengers, those guys who pick plastics. So they go to an incinerator or a trash can, and they're able to pick out the very essential, things that they are looking for. That looks like the life of a data scientist. So what is usually brought to a data scientist is raw data, messy data, ugly looking data. And then there's a need to turn that to beautiful insights. And that's one of the things that we are going to end up doing. What else do we see there? At the end of the day, it ensures efficiency and accuracy, and also reproducibility, which is a major concern in science. It's been reported that a lot of research are not reproducible for so many reasons. One, which is people don't openly share their results, their code, and their data. So at the end of the day, sometimes even researchers are unable to reproduce their own results. But we are going to learn some techniques that will help us to make this a lot easier. The workflow also involves multiple steps, from data collection to presentation, interpretation, and visualization. Therefore, the key objectives are: one, to organize and manage data effectively. Secondly, apply statistical and machine learning techniques. And lastly, communicate these findings in an actionable way. I love this first lecture so much because it sets the foundation, the basis for the other lectures. In addition, there are some concepts you are going to hear again and again before today's lecture. The reason for that is for you to internalize it so that it becomes your language. The goal is that we desire to make every one of us speak, data. So, to the real business. And this process rarely changes. The only additions, as we are going to say towards the end, could be subject specific. So, and if you are not going on with too much, go on with this one. These 6 core steps in a typical data science workflow. If you have a pen, a paper, and all that, you don't have to really write, but you can note some salient things that we are going to talk about. So the first thing is to understand. Sometimes this thing is called understanding the business, understanding the problem. Okay, so there's a research, suppose there's a research on determining the spread of a particular disease in an area. That problem is too ambiguous. First, spread of a particular disease in a particular area. So there's a need for you to understand that problem well. Because when you don't understand the problems, sometimes you have to come back to this first stage. However, it's also like that. As you go on, you need to go back and check the problem statements to see if the objectives have been well, defined. If the objectives will resolve the problem. Because if you don't have objectives that will resolve the problem, and you now eventually are able to meet those objectives, you'll be glad you met the objectives, yet the problem still exists. So I consider this a very important step, where you identify the problem or the question you are going to solve. Okay? There's really no need for data science if there's no problem to solve, just speaking generally. Then your next step under that heading is to define your objectives and then ask yourself, what are the constraints? Okay, and how do I measure my performance? So you define the objectives, you find the limitations, the constraints, and then what tool will I use to find out if I'm getting the desired results? And then you now engage stakeholders that you believe can be involved in that project so that you can achieve your desired, expectation. So as as simple as that first stage is, you are not moving forward if you don't have that. Because it's on that basis that you now know how and where to look for data, whether it's primary data, or do you need to look for secondary data, or are there databases that exist somewhere, or it's a difficult thing to get. Maybe you need to write to get an API, that's an application package interface that helps you to collect data from the owners. Sometimes you pay for them. Do we now need instruments to gather the data and all of that? Do we need to create maybe a questionnaire and all of that? That comes when you understand the problem. And that is very difficult. We've said it again. It's rare for you to have data sitting somewhere and then you solve the problem. Not common. Then you have to also ensure that the data you have is relevant, it's complete, and that it's going to get to you first on time, because sometimes you might have ended the project, because it's not even always that you have historical data. So there's historical data that has existed, but there's data collected maybe annually, maybe monthly, periodically, and all of that. But interesting to say that some data are collected hourly and sometimes continuously. You have to be sure of that. Are you relying on prior data, or you are merging that with current data, and do you need future data? Those questions need to be answered. And then data cleaning and pre-processing is where you now begin to use your skill in R programming. You handle missing data, outliers, data that are obviously inconsistent. Sometimes you might have duplicates, and it's important to convert data to a usable form. Okay, we need to know how to distinct. We need to even know the different data types. Okay, those that are numerical, those that are categorical. And then sometimes the data is such that the values are so wide apart, then you need statistical techniques like normalization and standardization. And there are occasions where you need to code the data. I'm saying all of this deliberately because at the end of the day, we are going to be implementing them in the next 9 to 10 weeks. All right. So we have seen defining the problem, collecting data, cleaning and pre-processing, and then performing EDA analysis, summary statistics, mean, median, mode, standard deviation, and all of that. And then check some visualization using plots, bar charts, graphs, and all of that. And then doing hypothesis testing and statistical inference. That's where it gets interesting. So once you start getting those results, you feel glad. But if you've not done steps 1, 2, and 3 properly, you get results, and those results might not change anything. And then the 5th step is model building and evaluation. So I know from experience that when people come to a data science class, this number 5 is what they are coming from. They are coming to learn machine learning. But yes, you will learn machine learning, but there are concepts that you need to know very well. And I can tell you, there's a lot of machine learning that will be done in this class. Okay, we'll do things like parameter tuning, we'll do evaluation, getting the metrics, and all of that. And finally, as we've said before, the most aesthetic and appealing part of this whole process is when you now begin to interpret with visualization, and you are now writing reports and making dashboards and presentations to stakeholders, and they are impressed with your results, provided those results can actually solve the problem. Okay, so we've started. Congratulations. So the first step is understanding the problem. For us today, we are not tackling any specific problem, so we won't be going that route. So the second stage is handling data, getting data. So here we present the types of data sources. For us here, there are 4 major types of data sources. There's structured data. It could be a database where you have a lot of different forms of data. And it can be a simple file, like an Excel file. That's structured data. It can be unstructured, like we said before, where you now have to process text, images, videos, sometimes neural signals, and a lot of other stuff. Okay. Then we said it could amount to getting access to private websites where you need permission, or public website where you can just scoop data. So we are going to look at how to get data for private websites using APIs, and also from public websites by simple web scraping. And finally, we'll look at more advanced methods like real-time streaming data. We'll talk about this as we proceed. So what are the immediate challenges in data collection? Data privacy and security concerns. Note that when I was talking about the APIs, I was saying private data. So that's a major concern. So again, to buttress the fact that data collection is a serious issue. In our classes, you have to be introduced to databases where you can actually get data for free. We also bring data. We also show you, we have, already pre-made data that we can use. But in the field, in actual practice, there might be need for you to look into these issues of privacy and security concerns, because when you use data, it's good to give attribution. It's good to reference, cite the owners of the data so that you don't get yourself into trouble. You're trying to solve one problem and you end up in trouble. Then we'll look at the challenges when you have data in inconsistent formats, serious issues. Okay, so your machine learning models, your data science methodologies require data to be in particular structures. We see that today. So when you don't have those structures, they can be really, difficult things to resolve. Then what about storage and scalability? Allow me to quickly speak to storage before scalability. Don't use your phone for R programming. Okay, you'll be compromising your phone. I mean your mobile phone. Better you use your laptop. Okay, but your laptop is not going to be able to do some level of storage as you continue in this journey. But for this class, all of the work that we are going to do, your laptop should be able to cover that. Then when you now talk about scalability, still in line with the issue of storage, the solutions, the examples, and the exercises that we are doing here, in terms of scale, they are narrow. But as you develop skill, you will need to learn how to manage huge amount of data. Let me go back to the class and see how I can add people. I don't know whether people have been added or have denied people opportunity of joining the class for some time. So where do I go? How do I know if people are joining now? Okay, we'll go here. So altogether, we have 37 people in class. Let me pause and ask 2-3 people to just respond. What is it that you have taken away from what we have done so far? Unmute yourself. This is 1 hour into the class, even though we've done about 30-40 minutes of lecture. I want to pause and give opportunity. Yes, Morufu, please pardon me.
Hello.
If I have not used Mr., Mrs., Dr. and Prof. Yeah, go on, please.
Hello.
Hello, go on, please.
Thank you very much for the presentations. It's well loaded. Although this is a second lecture, my name is Dr. Olubode Adeoye from Federal School of Statistics.
Okay,
so in fact, I find the lecture very, very interesting, but well loaded. But thank God you have said that you will be taking it a little by little.
Yes.
So I appreciate for that. But by the time you are doing that, presently I don't have much questions. But when you are going, but I just want to appreciate you. When you are going, in fact, the lecture was very, very perfect. So thank you very much. We will need, hello, are you hearing me?
Go on, sir.
We will need the soft copy in our mail of these presentations.
Okay, sir. Don't
So
worry.
and the first lecture too. In
Okay.
fact, the lecture is well loaded. And the way you
Okay.
are prepared is you want to bring up. So thank you very much for the presentations. Thank
Thank
you
you
very
very
much.
much. Thank you
Yes, sir.
very much, sir. Okay, so these lectures were prepared by Professor Olubuse, and you should know him. He does a very good job. He's my he's my boss. Then the other thing is you are going to get them. The third thing is this is the first lecture that we are having. The next thing is that we are just giving you a high level view. At the end of the second half of this class, you would have done some practical demonstration. So I think our brother has said enough. Let's not spend too much time, talking. Am I still sharing my screen, please? Hello? Am I still sharing my screen, please?
Yes.
Yes, yes.
Yes, we
Oh,
are hearing it.
brilliant,
Yes.
brilliant. Great. So welcome to the second half of our class.
Yes.
So
Thank you.
yeah, so this is the second half of our class. The first half of our class is to get ourselves acquainted to data science and to tell us that the data science has steps. The first step in data science, understanding the problem. And we have said we are not going to look into that really because later on we will focus on specific problems. The second thing that we have said is that we now have data collection. Data collection is a serious matter, and we've spoken about that. Here, we want to talk about data cleaning and pre-processing. So what I'm going to do is I'm going to now ask us questions because now it becomes very important for us to find out, have we downloaded the package, the R package? Did we? Hello? Hello?
Yes, sir.
Are there people here who have not downloaded the R package?
Yes.
Okay, good.
Yes, sir.
Yes.
Okay, so
Yet to be downloaded.
go to the platform, download that package. Give me 2 minutes to change the source of my energy. I want to change the source of electricity. I'll join you in 2 minutes, please. Please.
same thing tó ṣe lánàá náà nìyẹn tó ṣe tẹ̀síra nù ká tó fi mí sí jímọ̀ wàláhì tàláhì máa ń nẹ̀ ẹ́ sìn kó bọ́ta.
kí ló ń da dúbà yìí sí náà.
rèké mi wà ìyá fàtí ló rà á ó ló fún ọmú wá fún mi ó mú náà àbọ̀ òmú lọ́wọ́ tó yà mo ṣe ìbí ṣé ó mú náà àbọ̀ òmú lọ́wọ́ ó wá fẹ́ mú lọ lékè ó. rọ́bìtì tó ṣe lánàá náà nìyẹn á títí tí Fatima dóde tó fi mí sírun.
ní kí àwọn méjèèjì àbí.
Ibi la wà kí ló ṣe ọ ó kàn sunkún ni kí ni wàhálà ó sunkún títí tí.
kí ló máa ń ṣe náà ayọ̀ náà nìyá àbí dábì lóhùn ẹbí ẹ̀kọ́ ẹbí tó kó bọ́ náà ẹbí ẹ̀kọ́.
This man should meet himself now. What's the meaning of all this?
Hello, I'm back. Can you hear me? Can you see me?
Welcome back. We can see you.
Yeah.
We can hear you.
Okay, thank you very much. I lost connection because the lights went off. Now I'm having issues again. Just hello, everyone. Yeah. Can you hear me and see me? Can you hear me, see me?
Sure.
Yes, we can hear you, we can see you.
Yeah, so thank God we are in Nigeria. You understand what happened? So they took the lights and internet went off. But don't worry, we'll be okay. So let me share my screen again. This is the practical part of the class. So don't worry if you are not able to get everything. Okay, but I believe that you get most of the things that we are going to be looking at. So if you can see my PowerPoint, let me know.
Yes, clear
Yes,
and
we can
visible.
see. We can see here.
Okay, good. Good. So this is where you begin to implement R programming. You have data that is messy. You want to clean it. You want to put it in a format that can be useful for other stages of your data science work. So why is data cleaning important? You know that in computer science, we say it is garbage in, garbage out. So if you have data that is poor, it will give you inaccurate results. So we need data cleaning to ensure high quality, consistent, and reliable data sets. In fact, this field is a very lucrative field because not many data scientists want to work in this field. This looks like the house cleaning part of data science. You know, everybody wants to be the boss. Everybody wants to be the house owner, not the maid, not the servant. So this aspect of cleaning data is a very lucrative job. You can get jobs even remotely. Okay, I don't like it. Okay, I don't like it because it's tedious and they are not the well-paid people. Okay, the other thing is, what is data cleaning all about? It's about handling missing values. So the question is, if you have values that are missing, what do you do? Do you remove them or not? So we are going to be looking at how to remove such values and why we should do that. And if we are not removing them, you know, there's a row and there are some missing values. Let's say that there is a Mrs. B in this class, and we are looking at age, level of education, state of origin, and we found out that the state of origin is missing for that individual. Do we take up that individual entirely, or do we just replace that state by a random state? So that's where we talk about imputation. And then sometimes, because of error in entering data, there could be issues where there are duplicates. How do we handle when there are duplicate values or values that are so different? For instance, it is common when you have date of birth and you expect people to write things like 52, 48, 36, 12, 15, and then you see 1,950. Okay, so how can somebody be 1,950 years old? Then you should be able to, you know, look for ways around. That would just mean that the person has written the year such fellow was born. Okay, then we'll look at how you can standardize your formats, because again, when it comes to date and time, it can be very confusing because sometimes people write dates in different forms. You can have 12/11/2025. You can have November 11th, 2025. You can have 11th Nov 2025. So all those different date structures, we need to see how to match them together. And all of these that we've said can be referred to as data engineering. But beyond the data itself, there are now, you know, columns, variables, features. So at this point, we get to a bit of practical class, and then we go online. I'm doing this deliberately because this is the life of a data scientist, searching online. Okay. So some of the things I'm going to do in this next lecture might not be contained in the material, but there are tools, there are methods that will help you. You don't need to have everything in your brain. That brain will burst. But you need to know where to get information from. So for instance, now I need a whiteboard. So I can write whiteboard and then put online. And then I have that. And then I can pick this free online board because I want to use this to teach something. So I can go here and then write a normal equation, which we can call a function. So we can say y is equal to beta x. I think all of us should know this. But if you don't know this, you should know y is equal to ax plus b, where ax plus b is the equation of a straight line. I hope I'm not speaking too much of maths. Don't run away from the class yet. So what we are saying is you have y, which is what you want to predict. That is your dependent variable. That's what you are trying to forecast. And then you have x, which is what you need to predict the y. Let's give an example. Suppose we want to get the price of a house. The price of a house. That's what we want to get. And we are now saying the price of a house is determined by some variables. Maybe the age of the house. That the newer the house, the higher the price. And we said that's not the only thing that can determine the price of the house. The number of rooms can also determine the price of a house. What else can determine the price of a house? Maybe the location. So the age, what's our now? Number of rooms and the location are now referred to as features. So the features are the independent variables, whereas this price is referred to as the target. I had to do that because of the content here. So the content here says that feature engineering to extract meaningful insights. So by the time you have several features, in this example, we have just 3 features. Sometimes you can have hundreds of features. Good. So when you have just 3 features, you might not have the kind of problem that we are trying to describe, because not all features are going to contribute to this output, this target. So there might be need for you to drop some features, merge some features, introduce new features. So that process of dropping features, adding features, merging features is what we call, part of it is what we call feature engineering. Okay, so we will do EDA. We've talked about that before. We'll also do inferential analysis, including hypothesis testing and, confidence interval and regression analysis. And we've talked about telling stories. If you don't back up your presentation with something that the users will enjoy, then you will not carry them along and they might not even adopt your solution. So there's a need to make sure that you learn the skills of presenting your results in an enjoyable manner in form of a story, okay, but with the goal of helping your users to make informed decisions. So with regards to the tools we mentioned earlier, we are using R. So since we are sending you these slides, or these slides are already in the classroom. In fact, moving forward, it's possible for you to get this note. This note had been there for some time, but because it's our first lecture, so you will have access to this. But we are looking at R, not Python, SQL, Excel, Tableau, or Power BI. The goal is for computing and visualization, and we are going to use these 3 packages, and not just them alone, and many more packages. Many more packages. So we will use R, okay, because our focus is statistical computing and data visualization. But Python is also a very competitive programming language for artificial intelligence and machine learning. Okay, SQL, Excel, Power BI are other tools, which is not what we are focusing on now, maybe in the future. What then is R programming? So welcome to R programming. Okay, so this is the second part of the lecture, like I said, the R programming part, which we've already started. Is an open source programming language. What it means is that you don't pay to download R. There are other programming languages like MATLAB. You need to pay to use it legitimately. Okay, so I know that there are people who use clone versions and all of that. Those things are not legal too. But some people say we live in Nigeria. I leave you to decide that one. But the most significant thing is that when it comes to R, you don't have that problem. And that's why we are using it. And that's why we love it. Okay. It was originally designed for statistical computing. In fact, it used to be S. This language is from S. There's a language called S. But now, because of the work of some scientists, which we might talk about as we go on, okay, and the graphic capabilities of the language, it is now referred to as R. So we have the R base, and then there's R Studio. We are going to download two softwares. We'll download R, and then we'll download R Studio. The difference between R and R Studio is, number one, you need to have R before you get R Studio. Okay, so if you don't have R, you can't use R Studio. Secondly, R Studio has some extra features, which makes it easier to interact with and also present results. There is so much in that R environment, some of which we'll show you now, and others will evolve to learn about them. So it's used widely in data analysis, visualization, and machine learning, developed by Ross Iker and Robert Gentleman in 1900s. Some of the commonest libraries in R are ggplot, dplri for data manipulation, Caret for machine learning, tidyverse for collection of data science packages. So, applied for data analysis, for data visualization, machine learning, data wrangling, and cleaning. Note here that we said supervised and unsupervised learning using Caret and random forest. We are going to delve deeply into some of these concepts. So we have said before, in business and finance, in healthcare and government policy making. We said again, we are using R package because it is free and open source, no license fees required. It's built for statistical analysis, it's good for visualization, and there is a healthy community willing to help. Okay, so if you run into an error, which is something that we'll run into again and again, there is an existing community that you can reach out to. And then that error that you have faced, that problem, that bug that you have faced in your code, there's the likelihood that somebody else has witnessed it and the solution has been, made available. Then you can install R on your Windows, on your Mac OS, on your Linux. I use Windows, and I think many people that I've met use Windows. I hope we all use Windows. So how do we install R? We go to the CRAN website. So I'm going to demonstrate it. I'm going to share it, and I hope we all have R Studio downloaded. If we have R and R Studio downloaded, then we can begin to show you these four interfaces practically before we start doing, computation. Good. So I'll go to our classroom, our WhatsApp page. From our WhatsApp page. Okay, so where are we now? We can go back. So we have allowed a lot of work so that those who have joined late, will be able to benefit. But from now on, we are going to a region where if you miss from here, it might be very difficult for you to catch up. So I could actually go online. Let me go online and look for that CRAN. So for those of us who are not here, who are going to watch this video later, all you just need to do is to open a tab and write install R and R Studio on Windows. Okay. Or simply, if you want to install them one after the other, you can say install R for Windows. This first link that you get to, you will click on that link. So I'm going to copy this link, put it on our platform. The real work has started. Please, let's begin to implement. Okay. So we have that. I'm going to give a few seconds for us to get to that. For those of you who have not installed, once you have done that, you now come to download this software. You click on it, and then it downloads. It downloads. So if you go to your downloads, you'll find it there. After downloading, you will need to install. Okay? So what I'm going to do is I'm going to go to my downloads and show you that it's downloading. It's downloading. And so long as it's unconfirmed, it means that it is still downloading. Once the download is complete, we will now run it, and that's the installation. As you run it, all of the windows that come up, just accept them. Let me see if I can get out in my downloads. If I can get out that I've downloaded before, I will run it. But if I don't get it, I will have to wait for this to get out. Yes, did somebody raise hands? This is where people will start raising hands. This is Mercy Olugu. Yes, go on. Maybe that was accidental. For those of us who were successful in downloading R, we now need to download R Studio. How do we do that? We open a new tab, and then we do R Studio. Download. R Studio download. Then you pick this very first one. You can watch the videos later and it will help you. Then when you pick that, this is an IDE. Okay, it's not just an editor. Then you go to install R Studio for Windows. This is the one that you pick, and then it downloads. As you can see here, there's a number 2 here, which shows that I'm downloading both R and R Studio. But we are going to fast forward. We are going to assume that you have downloaded R Studio and R. And what you are going to, when you are done, is an interface that looks like this. I'm going to delete this stuff. I've deleted everything. I can do Ctrl Z and bring it back later. But for now, I've deleted it. That's what I want to do. So you are going to have this interface. Remember that we could also send you a video that will help you to download and install, but let's listen to the lectures. So if I go to our notes, these notes, we will see that in the R Studio, which is built on top of R, which is different from R, which we can show to you at another demonstration, there are 4 regions, 4 pens. One is the source pen. The other one is the console pen. Then there's the environment pen and the files pen. So what I'm going to do is this. I'm going to try to put this together so that we can have this together. Okay. So let me reduce this. I hope you can see my screen. So here is the source. This is where you write your script. This is where you do your coding. This is the place. Then we have the console under here. You can also write here and do 2 + 3 and press enter. It will give you a result. It's possible. So this is your R base. Remember I said you need to download R and R Studio. If you had downloaded R, you could do your work in R. Your R looks like this region. Let me pause and ask, can you still hear me or I'm on my own? Because we've entered practical now. When you're in practical, you need to be sure people are listening to you. Are you with me, please, class?
Yes,
Yes,
we
sir, we
can
can
hear
hear
you.
you.
Yes, we can hear you, sir. We are with you,
Fantastic.
sir.
Fantastic. So there are 4 pens in this R
We
Studio.
can hear you, sir.
But if it was only R, you only have access to only the console. That's why we use R Studio. So this is where you write your code. This is where you have what we call your terminal that can link to your back end. And this is where you have your console that can link to your front end. Don't worry about all of that. Then here we have the environment pen. This is where you can load your data sets and get your variables. For instance, if I have a variable called age, and I say age is equal to 10, we'll come to this later, and I press enter. In this portion, we will see age already identified. That means a variable has been created, which is age, and the value inside is 10. That's what this part does. In this place, this last one, we have things like files, plots, packages, and a lot of stuff. So what am I saying? I'm saying, introducing you to the R Studio, there are 4 panes, 4 regions. There is the source where you put the code. There's the console. There's this environment. Somebody wants me to just attend to issues. Okay, let's go. Let's see who that person is. Mercy Olugu, you are raising your hand. Deliberate or accidental? Hello? Okay, let's go on. So I kept hearing that sound. So there's the source, there's the console, there's the environment where you load your data set, and there's this place where you get your files, your plots, your packages. This is where you install your packages. And there are some packages that come with R. If I scroll down, you can see ggplot. ggplot should be one of the packages that come with it. See, your DPLR package is for data table and back end. There's the E1071, okay, for statistics and probability. If you scroll down, I want to see the ggplot. Okay, so there's the ggplot 2 to create elegant visualization. So there are packages that you can call, and there are, packages that you can install. Okay, so those are the 4 different. Then if you want to clean any of these regions, then you can use this, your broom, to clean that space and clean that space and clean that space. So I can do Ctrl Z and bring back my notes. So these notes are from our classroom. Okay, so let's go through the notes. So let me try to see how far we can go. So we can use R for addition. And how do we run the lines in R? By the way, I can decide to create a new file for all of this. I'll go to File. It's a new file. And there are different types of files that you can create. You can create notebooks, R Markdown. You can create a web app with R. You can link it up with other programming languages. There is so much that you can do. For us, we start with the R script. So if I click on R scripts, it will create a clean file. I can then save that file. I'll go to File. I'll say Save As. It will tell me where do I want to save it. For now, I want to save it on my desktop. On my desktop, I have many folders, but I want to put it in Professor Lubuse's folder. And inside Professor Lubuse's folder, I want to just leave it as a file. So I'm going to call it lecture 1 underscore FSS, which is Federal School of Statistics. It says the file type is R. So when I save this file, it will be lecture 1 underscore FSS dot R. So I've saved that file. Now, in this space, I can write code and I can write notes. Okay. If I want to write notes, then I use hashtag. That hashtag is for comments. So I can say, this is my first note. And then I can say 4 plus 34. How do I run this? There is an icon here which says run. If I click on it, it will run. And then it produces the result here, 38. But it's not this far that I want to run. I want to run this one. Okay. And this note, someone is not, there's noise somewhere. Where is that noise from? Karim Odugbemi, can you mute? Karim.
Hello, good afternoon.
Please mute. Yeah, mute. Thank you very much. Thank you very, very, very much. Great. Okay, so this is, I only put these 3 hashtags to show that this is a major heading. So we want to run basic commands in R. Can you see my screen? Is it clear? Is it clear? I need help. Is this clear?
Yes, clear.
Yes, sir.
Okay, good.
Yes,
Good. So
very
in
clear.
R, we can do arithmetic operations. For instance, we can add 2 to 3. Notice that I put hashtag here and I put addition. This means that I'm just writing a comment that this symbol plus is for addition. So if I put my cursor anywhere around here and I click on run, it's going to give me the result, which is 5 here. So, and that calculation is correct. If I run the next line of code, it will give me 6. So this asterisk is the symbol for multiplication. That will give me 12. And then this one is for division. And that will give me 3. This 5 caret 2 means 5 raised to the power of 2. That's 5 squared, which is 25. So if I run that, you will see that it's already working. So one of the exercises that you are going to do later on, but all your exercises are going to come together at the end. The reason for that is we've had problems with people joining, we've had interruptions and all of that. But moving forward, we'll follow the curriculum strictly. For today, the goal is to cover as much as possible and to have you demonstrate it, because some of us have not even downloaded the package. I hope that makes sense. The next thing we are looking at is looking at how to create a variable. Okay, so variables are created on the left-hand side of our equation, if you like. And in front of the equation, we should have the equal to sign. The equal to sign is accepted, is completely legitimate. But as a convention in R, we use the less than with the dash notation. So what this means is that this X is a container, is a variable. Inside X is the value 5. So line 17 says that create a variable X and the value will be 5. So if I run that line, we have created a variable X, which is 5. There's no error here. In this environment, we see that there's a new variable and the value is 5. So if I run line 18, a new variable will be created and the value will be 10. We can now take those 2 variables and bring them together using a mathematical symbol, which is addition. And then we create a fresh variable. We want to call that variable the sum of X and Y using the name sum underscore XY. So if I run line 19, what line 19 will do is it has created a variable. Inside that variable, some computation is taking place. It is adding X to Y. If we want to see the output, we use this function. So print is a way to get output. And after writing print, you're supposed to put a bracket in front and then write what you actually want to see. For instance, if I want to see y, I will say print y. But before we get to that, printing the sum of x and y should give us 15 because 10 plus 5 is 15. So if I run that line, we'll get 15. If I run print y, you can guess the answer will be 10. So we'll have 10. So that's the introduction. With this one, it shows that your R Studio is working. For instance, we are seeing the results in the console. We are seeing variables created in the environment, and we are writing in this source area. Moving on. Let's look at another data structure. So it's not always that you have a single value. Sometimes you can have several values of the same characteristics. So when we have values of the same characteristics, we call them vectors. In this case, our vector refers to numbers 1, 2, 3, 4, 5. They are all of the same nature. I can use another variable, maybe names, and I can have Ayo, Bola, Chinenye, Ahmed, and all of that. So for now, we have created a variable. The name of the variable is numbers. We now want to assign to that variable, and that's why we have used this less than with dash, which I said we can also use equal to. This C here is the function for creating a vector. This print is the function for seeing your output. And when you use a function, you put a bracket in front. So in the same way, we are using the function C that we use to create a vector, and we have put brackets. Inside, we have 5 items separated by comma. So if I do this and I run this line of code, wow, somebody wants to join the class. This is difficult. So where do we go? Let's admit the person. I hope we are doing fine. I just hope so. So if I write numbers, and I run that line, just numbers, I will get an error. Why will I get an error? It doesn't know number. What it knows is numbers. So it's going to give me an error. So don't be scared when you have errors, although we all don't like errors. So what you do, I put an S there, and then if I run that line of code, it will tell me that inside your numbers, there is one row, and in that row, you have the numbers 1, 2, 3, 4, 5. If I ask it to print it, it's going to print it. So the idea of printing, okay, is similar to just calling the numbers. Then the next data structure we have is matrices. So I don't know whether we should know what matrices are, because we might have people. Yeah, it's important to quickly say this here, this one here, whiteboard. It's important because later on we might run into issues trying to explain the further part of this lecture. So a matrix is actually made up of rows and columns. So if I have 1, 4, and 3, this is a vector. Okay, one row. If I have another and I call this 2, 1, 1, this becomes a matrix. A matrix that has row 1, row 2, and has column 1, column 2, and column 3. So this is the structure of a matrix. Okay, so we go on. So when we say matrices, we are referring to such structures. If we want to create a matrix, we use the matrix function. Don't forget, if we want to create a vector, we use this C function. If we want to create a matrix, we use the matrix function. The matrix that we're about to create is a matrix of numbers, beginning from 1 up to figure 9. Somebody's joining the class also. Sometimes some people don't have strong internet, so that's why you have some of these things. They come in and go up, off. So the name of our matrix, that's the variable, is matrix underscore example. Then we assign. What do we assign to it? A matrix of numbers beginning from 1 and ending at 9, making sure that we have 3 rows and 3 columns. 3 multiplied by 3 should give us 9. If these things do not agree, you will not create a proper matrix. So we run that line, we have a matrix, and then we can print it out. And once we print it out, we will see that this is column 1. This one refers to row 1. This value here, this one means row 1. This value here means row 2. This one means row 3. So when you do row 1, comma, you are trying to call the whole of row 1. If you do row 2, comma, you are calling the whole of row 2. If you do row 3, comma, you are calling the whole of row 3. But if you do comma 1, you are calling the whole of column 1, and so on. So we have seen vectors, we have seen matrices. We now want to see data frame, which is the interesting part, because for the purpose of analysis, we actually want a data frame. We can create data frames for ourselves, and we can use existing data frames. So let's try to create a data frame. How do we do that? We get a variable name. DF is a convention from data frame. Okay, so you might see that again and again come up. So what do we need? We need a function. To create a vector, you use C. To create a matrix, you use matrix. To create a data frame, you use data.frame. Now, with data frame, there's something interesting. What is interesting? In a data frame, you can have rows and columns, okay? And the rows, you know, the columns might have different types of variables. We'll talk about variables later. So in this particular data frame, there's a column for name and there's a column for age, okay? And in the name, we now have a vector. That is 2 individuals. The individuals are Alice and Bob. Note that we have quotation marks, because when you write letters, you use quotation marks. When you write numbers, you don't use quotation marks. And make sure that the quotation marks agree. If you use double quotation marks here, you must replicate it here. So this gives us, this can create a data frame. So if I run line 36, I would have created a data frame. But if I run line 37, I will now see a data frame. So the data frame that I created in line 36 is what is printed out here. So if we put an extra individual, for instance, let's not put an extra individual for now. Let's just keep going because we don't actually have enough time. So you can actually put an extra individual. But when you put that extra individual, you also have to put an extra age. So if I put my name here, Peter, I must put age, say 20. So we have number row 3, where you have Peter, and then you have the age. So at this point, with respect to your notes, you are supposed to do a hands-on exercise. The hands-on exercise I'm going to copy. This time around is going to be a take-home for everyone. The reason being that some of us have not even downloaded the R Studio and the R app. Okay, so I'll paste that exercise there and send it to the group. So this could serve as something that will help you to revise today's work. What are you expected to do in that practical demonstration, which you can do immediately after this class? Let me remove this comment so that you can see it. Number 1, you open R Studio and confirm R is working by doing all those computations. Then the next thing is you run basic arithmetic operation like addition, subtraction, exponentiation, and all of that. And then you use the print function to check out the values. And lastly, you also use the C function for vectors. So that's what I will expect you to do. We don't have, enough time to do what I expect will be very obvious. But let me pause and find out if I'm running too fast. So as I stop, I'm going back to the notes. Yes, just one person to make comment, and then we'll go on. Yes, just one person. Please, let's go on. Let's hear you. So we've done this. We've done this. We've done this. Okay, so we're supposed to talk about comments and saving files. We've done that. We are here on this stuff. And then we keep going. We keep going. We've done this also. Touch this. So what I wanted you to see is that we're actually making progress in the material that we are expected to use. And if nobody is making any comments, I take it that we are okay.
Well, let me say just a little things. Like you have done wonderfully well. And the comment I have is the break in network is not giving us, at times we will not get some things we are supposed to get. That is the challenge here. Okay. So in fact, we are missing some of the cogent points you have displayed.
Okay.
So but the experts are giving us, we try and see so that we can have a revisions of it during the next time we meet.
Okay, so
it's
good point. Very good point, sir. What I can tell you is that when you watch the videos, all those times that you were off or that I was off will be taken care of. Okay, so let's go to Ademola Phillips. Yes, go on. Ademola Phillips, your hand is up. Is it accidental or deliberate? Yeah, okay, so I don't know whether it's accidental, but let's just keep going because you have access to the video and that will really make a difference. Okay.
Yes,
so yes. So moving forward, you don't only have numbers, you also have letters. Okay, they are called characters. You also have booleans. So if we are talking about data types, we have numbers, we have letters, and we have booleans, true or false. Okay, so those are three major data types. So here in line 49, we have created a new variable called character vector. And here we have the vector because we have used the C function, and the things inside are actually written in letters. That's why we have used quotation marks and separated them by comma. So if we run this line of code, you will see that we have created that variable. Here we have created another variable called logical vectors. If we run that line, what you have done in line 49 and 50 is that you have stored these values inside these variables. They are now inside. You can now call them. So calling them means, say, print. So print is, tell me what is inside character vector. If you do that, it will tell you inside character vector, we have apple, banana, and cherry. If you ask it what is inside the logical vector and you run that line, it will tell you that we have true, false, and true. Moving forward, it is possible for you to now locate specific elements inside each of those variables. That looks like big grammar. What we are saying is we have a variable called character vector. We want to locate cherry, we want to locate banana, we want to locate apple. We can locate anyone. For instance, if we want to locate banana in character vector, we will just say character vector, the number. But remember that we've already created a variable called number. Okay, so what we have here is that we want to access. Okay, so let's leave this number vector. Let's come to this 58 first because it's so close to us. So we have a variable called character vector. Inside character vector, we have apple, banana, and cherry. Apple is in position 1, banana is in position 2, cherry is in position 3. So if I want to get banana, I will go to character vector and I'll put number 2 if it is banana. But what I want to retrieve here is apple. So apple is in position 1. So I will name the variable, which is character vector, put a square bracket, and put the number 1 inside. It will retrieve for me apple, as you can see here. And if I like, I can say print bracket character underscore vector, and then we'll run that, and then we'll see apple, banana, and cherry. But if I put a square bracket inside and I write number 3, okay, because cherry is the third one, if I run that line, it's going to give me only cherry. So that's that about retrieving elements in particular positions. But again, with vectors, we can go on with vectors and create a list. So let's go to our notes and read a few things so that we'll be, up to speed with the notes that we are using. So here we have X is equal to 10 is numeric. Y is LO is a character scalar because it's just one. Z is true is a logical scalar. So a scalar refers to just one value. So scalars are technically vectors of length 1 in R. Vectors are one-dimensional arrays containing elements of the same data type. To create them, you use the C function. And there are examples which we have seen. If we want to access an element, We'll first create the vector, and then we retrieve it from its position. That's what we saw in our R studio. So for lists, what do lists do? Lists store multiple types of data. They are able to store both numerical and character data, and even vectors. So in this example, you see on the screen, somebody wants to join the class also. So let's go and add that person to the class. Oh, the person has joined. Great, fantastic. Fantastic, brilliant. So where are we now? To create a list, we use a list function. To create a matrix, use a matrix function. To create a vector, use the C function. To create a data frame, use data.frame. So I create a variable, my list, my underscore list. Now have this function. In this particular example, we have name. The individual is John. His age is 30. His scores in his test are 80, 90, and some other number. Okay. So if I go to my code, we will see it here. So my list, using list function, the name is John with quotation. The age is 30. The score is 80, 90, 85. If I run this line 70 and I print line 71, it will give me the name John. It will give me the age 30. It will give me the scores 80, 90, 85. If I want to retrieve an element, this is very interesting. If I want to retrieve an element from a list, very important. What I'm going to do is I'm going to name the list and then use this $sign and attach it to the part of the list that I want to get. Don't forget that in your list, you have name, you have age, and score. So if you want to get name, you give us the name of the variable and then use $sign to extract the name. In our own case, it will give us John. If it is the score that you want, you write my list $score. But if it's a specific score, you put square bracket, in this case 20. So for us, in our example and in our practical demonstration, if we go to my underscore list $name and I run that line, I'm going to have John. If I run my underscore list without the 2, I'm going to have 80, 90, and 85. If I want 85, I'll put square bracket and put 3 because 85 is the third number. If I run that, I'm going to have 85. How do we demonstrate matrices? We go back to our notes and then we look at matrices. This might be a bit challenging, but let's try. Matrices store data in rows and columns containing elements of the same type. They are created using the matrix function. This is an example that we have seen before. Okay, good. If we want to retrieve elements in row 2, column 3, if you want to retrieve the whole of column 1, if you want to retrieve the whole of row 1, so we go back to our code and then we demonstrate this. We scroll down and then first of all, let's recall our matrix. That's our matrix. We print it out. If we want to get elements in row 2, this is row 2 here, 2, 5, and 8. But we want column 3. That means we want only 8. If we run this line, it should give us 8. If we run the following line, this following line will give us the whole of column 1, which is 7, 8, and 9. This next one will give us the whole of row 1, 1, 4, and 7. Let's confirm. Line 88, we run that. It gives us 8 because we are looking for row 2, column 3. This one will give us the entire column 1. 1, 2, 3, this first column. The next one will give us the entire of row 1, 1, 4, 7. So it's possible to extract a full row, a full column, and specific elements. Sometimes you can even pick elements within a particular range. So we've done matrices. Let's now look at data frames. which are the closest to what we'll be using in practice. So data frames store tabular data. They are like Excel sheets. If you want to create them, use the data.frame function. This is how to create them. We've seen in this example, we have 3 vectors. Why? Because we are using the C function. This looks complicated, but let's talk about it quickly. You have a variable called students. You want to assign things inside, but you want it to be a data frame, not a matrix. That's why you're using data.frame. Then you need 3 columns: name, age, and score. So you pick the 3 columns. Each of them will be a vector containing 3 items. The first one containing characters, the second one containing numbers, and the third one containing numbers. So this is what we are going to create. So when you run, this is what you are going to get. Okay? And we can actually ask, oh, somebody is disturbing us again. Hello? Who is that? Hello? Who now? Ahmad Usman. Ahmad Usman. Ahmad Usman, please mute. Ahmad Usman, please mute your computer, please. Okay, good, great. So let's go to the code. Remember that we are recording this, so there's an added advantage. So we create our variable, which is student. Inside student, we use the data frame function. And when you print out, we are going to create this data frame. So if we go down beyond that, we'll be talking about retrieving elements. If we want to retrieve only the names, we will write the name of our variable, which is student, add the $sign, and call the column that we want. The column we want is name. If you run that, it will give us the names: Alice, Bob, and Charlie. If we want to retrieve the entire second row, that is this row of Bob, that's what we want, so that we can get Bob, 24, and 90. We will call the variable, which is student, put a square bracket, say we need the whole of row 2. We won't tell you what particular column we want. So we'll run that. If we want to get the entire third column, where you have this course, you write the name of the variable, which is student, put a square bracket. You won't put anything in this first part, meaning that you need everything in that column. And then when you now do this, it means that you need the third column. So you go and run that, and then you have only this course. Now, beyond just having data in data frames, the kind of data you have can actually be at different levels. For instance, they can be in categories. So we have what we call categorical data. And with categorical data, it's better for us to introduce what we call factors, so that we can know the number of levels that we have. What do we mean? Using gender as an example, in our own case, we have only 2 levels. The levels are male and female. So what I'm going to do now is quickly go back to the notes, show you that what we have covered so far is just a little above half of what we're supposed to do. But if we take 20 more minutes, we'll finish this material. So let me pause and ask for your opinion, because we've done one part of the lecture, which is getting us together in class, introducing the material, but we've not completed this practical demonstration. So I'll be glad if you can spare us an extra 15 minutes. But if you think that will be too much for us, we can actually add it to another. Okay, somebody is saying we need to jump to another meeting. So let me round off this in 2 minutes. Okay, let me round off this in 2 minutes. So we've seen that we can have factors. So we are going to stop here today. But please do us a favor of going through this material, because again, some of the things you are going to see in the latter materials are things that are like what we have seen before. So that's why I'm trying to run some parts of the code so that we can get to where we have our next exercise. So go to the classroom. This is your exercise towards the next class. So in preparation for our next class, the first 20 minutes will be to complete this work and then move to part 2. But please do two things. One, download RStudio. Practice RStudio. Then go to the classroom, download this material, and try to run the code. Throughout this week, if you have issues, let us know so that we could address them. We could not have 2 hours because there were issues with people, joining, coming in with noise, and all of that. But I'm going to stop here, stop sharing my screen here, and then stop the recording also. I don't know if we can get 1 or 2 comments so that we'll be able to be guided for the next lecture. Over to you.